Okay, so common questions and calculations that you'll be asked to do with these analyzing rate functions. So the first really common thing that you're going to be expected to do is to figure out the amount that's been added or removed over a certain time interval. So for example, we're going to pretend that we're looking at, in this case, the interval from A to B, just so we can have a little bit of context here. So if I want to know the amount that's been added, all I'm going to have to do is find the integral of whatever my rate in function was over the interval from A to B. So in the last example, this would have been the integral from A to B of e of t dt, because that was my rate going in. If I want to know the amount of stuff that has been removed, then I know it's going to be the integral of the rate going out. And again, I like to always just kind of have a little bit more context, so from A to B. But that's all it is. For amount being added or removed, it's just the integral of the rate in or the integral of the rate out. Simple as that. If we want to find the current amount, then we know that the current amount is always going to start with the initial, because we started with something. And then we know that we're adding a certain amount of stuff to it because we've got stuff coming in. So it's going to be the rate in, in, and then we're going to be subtracting the amount that's going out. Oops, I forgot my dt up here. So it's the initial plus the integral of the rate in minus the integral of the rate out. So in other words, we could just say that the amount that's in there is the initial plus the integral of the rate in minus the rate out dt. So we could combine it as one integral as long as we've got the same bounds on the integrals. So if we're talking about, from 9 to 23 on both of them, then we would be able to use one integral to set it up. Otherwise, we could do two separate ones, but it's going to be initial plus the integral in minus the integral out. And you'll notice the integral in, that's the amount that was added. The integral out is the amount that was removed. So we're using these two pieces in this question also, okay? If we're going to look at the amount that is increasing and decreasing, or whether the amount is increasing or decreasing, there are a couple things we have to pay attention to. So the first thing we want to figure out is we want to know what is the rate in at that specific t value that we're looking at. The second thing we want to know is the rate out at that same t value. Okay, and then the third thing we're going to do is we're going to compare those values. So if we figure out that the rate in is greater than the rate out, we know that the amount is increasing. Right? If it's coming in faster than it's going out, then the overall amount must be increasing. If the out rate is greater than the in rate, we know that it's decreasing. Right? If the amount that's going out is faster than it's coming in, then we know the overall amount must be decreasing. Okay, to figure out the maximum amount or the minimum amount, there's a couple things we need to know there. So first of all, we're going to need to, I'm going to draw a line here. So we're going to first need to figure out the rate in minus the rate out, and we're going to set it equal to 0. And the reason that we're doing that is because the rate in minus the rate out is really the first derivative of the amount of stuff. and I'll show you that in a problem later. But the rate in minus the rate out, we're going to set it equal to 0, and we're going to solve for t. All right, and then the second thing that we're going to do is we're going to make an options chart. Because we know that in order to find a min or a max, we always need an options chart. So we're going to have our t values, and we're going to have the amount. In the t values, you're going to have your endpoints, and then you're also going to have the t values that you found in part 1. Okay, and then in terms of the how you figure out the amount, you're going to use this formula that we wrote up here. You're going to use this initial plus integral in minus integral out. And I will show you guys how to do that. Okay, find r prime of t and explain the meaning. So r prime of t, you guys can find a derivative, that's not a big deal, but we need to talk about what it actually means. So r prime of t represents the rate at which whatever your original function is changing measured in whatever your units are, which this is hard to do, but we're going to write units per time, oops. So measured in units per time. So really, if you think about it, if we're taking the derivative of something that's already a rate, I like to think of it kind of as acceleration. So the units here would kind of be like meters per second squared or something like that. So it's units per time. So like I said, it could be something like meters per second squared. Okay, and then at time t equals whatever t value we're evaluating at. This one I know is hard. I know that's a little confusing. I promise I'm going to explain it in the problem we're going to do. Okay, and then the last thing, it's a little silly to have to write, but write an equation to find the time when the amount equals a certain number. Well, we already said what the amount is up here. We already said that the amount is the initial plus the integral of the rate in minus the integral of the rate out. And we're just going to set it equal to whatever number they tell us. Okay? So, sample problem number 1. Here's that same problem we were just looking at. Okay, so I'm not going to read the whole thing again. But here we know is the rate in. We know that this is the rate out. We've got our units there. E of t and L of t are people per hour. T is hours. And we know that the initial condition or the initial amount is right there. We've got 10 people in the park at time t equals 9. All right, so part A says find the number of people who have entered the park by 5 p.m., which they even told us is time t equals 17. So that's a good thing. Well, if we look, we want just the number of people who have entered. And then they gave us this time. So if I want to know how much has been added, if I look above, I know that that means it's going to be the integral of my rate in, which is E of t dt. And it's going to be from the time they open, which is at 9 a.m., until the time that they asked me for, which is 5 p.m., and so that's 17. So now you'll notice this is a calculator question, so you're going to need your calculator with you, which obviously I don't want you to have to do this. So we're going to go ahead and enter this into Y1 so that we can figure this out. So actually, do we need to? Yeah, let's do it. So Y1 is going to be this function. So 15,600 over x squared minus 24x plus 160. And so if I want to do the integral, I know that that's math 9, and I can do the integral from 9 to 17 of my y1. So that's going to mean go to variables, go to y variables, it's a function, and it's y1, and take the derivative. So we get 6004.270. So this is the number of people who have entered the park by 5 p.m. Now I know it's a little weird. We're not going to talk about rounding right now. We're just going to round to 3 decimal places because that's what AP always wants. So we're just going to leave it for now, okay? Find the number of people in the park at 5 p.m. So what this is really asking us for is just the current amount, or the amount at 5 p.m. So we know that the amount is going to equal the initial plus the integral from 9 to 17 of e of t dt, because that's my integral in. Oh, that wasn't what I wanted to do, but that's okay. Minus my integral out, so from 9 to 17 of L of t dt. So remember, this is in, that's out. So the amount is going to equal the initial, which was 10, plus these integrals, well, plus and then minus. So from 9 to 17 of e of t dt minus the integral from 9 to 17 of L of t dt. So we've already got e of t plugged into our calculator. We can go ahead and plug in L of t into y2. And so that's going to be 9890 over x squared minus 38x plus 370. Okay, and then we're just going to type this in exactly as it is. So 10 plus math 9 from 9 to 17. This one is going to be our y1, and then subtract the integral from 9 to 17 of, now I need y2. And I get that my answer is 3,735.163. So the number of people in the park at 5 p.m. is about 3,735. Okay? All right,